Section 6.2, Graphs of Other Trig Functions, Part 2. Your homework is problems 21, 27, 28, 29, 31, and 33. Part 2 will focus on graphs of secant and cosecant functions. I don't know if it's good news or bad news, but you are a pro at these problems already. You just don't know it. The reason why I say that you're a pro is because secant comes from graphing its reciprocal, which is, if it starts with the S, its reciprocal starts with the C. So cosine function. So if you know how to draw cosine, you know how to draw secant. If you know how to draw cosecant, it starts with the C, you can draw the one with the S, which is its reciprocal function, sine of x. So by knowing how to draw cosine and sine, you know how to draw cosecant and secant. Now, just like tangent functions, secant and cosecant have undefined values. Why do they have undefined values? We have undefined values because we need to remember that secant is made up of 1 over cosine. So we need to be careful when cosine is equal to 0, since cosine can be 0. Same thing for cosecant. We need to be careful when it has a denominator equal to 0, meaning when sine is equal to 0. So as we see here, we have a quick little image of our cosecant graph. And I like this picture because it kind of, without using directly an xy coordinate plane, we have our graph. We see where we have our undefined values at 0, pi, and 2 pi. And we see that we have these branches that look a lot like a parabola. We have this parabolic-like figures. No, they're not called a parabola, but if you refer to them as a parabola, I wouldn't be mad because that's a lot of what they look like. Now, how do we find these points? To graph cosecant and secant, we have these U-like figures with asymptotes. For secant functions, your domain is when x is not equal to 2n plus 1 times pi over 2, and n is an integer. Your range is from negative pi to negative 1, negative infinity to negative 1, and 1 to infinity. The graph has vertical asymptote at x equals 2n plus 1 times pi over 2. There are no x-intercepts, and your period is 2 pi. Now, how do we graph it? Your steps are quite fun because you've already done it all. First, you want to graph the reciprocal function. So you want to graph either sine or cosine. So it's important to know which is the reciprocal of which. Any x-intercepts of the reciprocal function are now vertical asymptotes of the cosecant or secant function. Sketch the graph of the desired function by drawing typical U-shaped branches between the asymptotes. The branches will be positive when its reciprocal function is positive and negative when its reciprocal function is negative. So let's draw y equals 2 secant of 1/2 x. To do so, you're actually going to begin by graphing its reciprocal. So y equals 2, the reciprocal of secant is cosine 1/2 x. All right, let's go ahead and begin graphing it. So I want to find the length of one period. So I'm going to take that and divide it by 4 pi, or we can stick to our rules and we bound it between 0 and 2 pi, whichever one you want. Okay, so we have 0 is less than or equal to pi over 2x, or 1 over 2x less than or equal to 2 pi. We go ahead and try to get x by itself, so let's multiply by 2 on both sides. So 0 times 2 is 0, less than or equal to x, less than or equal to 4 pi. So we have this as our interval. So our graph will range from 0 to 4 pi. That is our period. Now we want to find important points, so let's divide it by 4. To do that, let's subtract our high minus our low, high minus low. So I have 4 pi minus 0, which is just 4 pi. Now we're going to divide it by 4. So 4 pi divided by 4, we get pi. So the difference between each point will be pi. So I start at 0. And then the next one will be pi. Then we have 2 pi, 3 pi, and 0. Now we see that our amplitude would be up 2, and cosine starts at 1. So our first point would be 2. But you don't have to remember basics. You can just go ahead and plug it in. So if I have 2 times secant of 1/2 times 0, we have 2 times secant of 0. Secant at 0 is 1. 2 times 1 is 2. So we start at 2. 0, 2. Can you guess where your next point will be? Yes, our next point will be 0. Then we'll have -2, 0, and back at 2. Let's go ahead and label these points. So I have pi, 2 pi, 3 pi, and 4 pi. And I'm drawing sine. So I'm drawing cosine, I mean. So I start at 0, 2, pi, and 0, 2 pi, and -2, 3 pi, and 0, 4 pi, and 2. So if we graph our function, this will be our cosine function. And if we can really make it as long as we want. We can add another pi. So we have 5 pi, 6 pi, 7 pi. We can make it as long as we want because we know this sinusoidal function has a figure that it has, right? So we can continue as much as we want. I won't. I just want to show you that we can draw however many points you feel is necessary or your question asks for. Okay, this is a beautiful cosine graph, but it's not our graph. This is helping us find our actual graph. Our actual graph is y equals 2 secant of 1/2 x. To begin, let's go ahead and draw our asymptotes. Now our asymptotes are points that our graph will not cross. Our asymptotes happen at the middle point, where x is 0. So these are our asymptotes. Now how do we graph these U-shaped figures? These U-shaped figures come from where we have our peak, that is our point, and then we pull away. So we have our peak and we pull away. We have our peak and we pull away. And we know they're a U-shaped figure, so we can go ahead and finish off that branch. And there we have it. We have our graph of secant. Now I'll let you finish off these problems on your own. Remember, so what are your rules? You first want to graph the reciprocal function, meaning sine or cosine. To help you out, if you're being asked to graph secant of x, you have to graph cosine. If you're asked to graph cosecant of x, you graph sine. From there, your x-intercepts are your new asymptotes. And lastly, you draw U-shaped figures from the peaks, such as we did here. All right, like I said, you're already a pro. It's just a matter of adding those extra steps. This was section 6.2, part 2, graphs of secant and cosecant functions. Thanks.